Welcome, and today I'm going to be showing you a classical chemistry demonstration. This is called the blue bottle experiment, and it's used to show kinetics of a chemical reaction. Now, kinetics are the speed at which a reaction happens. And fun story, last weekend I had to go do a demonstration for some Cub Scouts, and it was really cold. And funny enough, it barely worked. Luckily, it's nice and warm in here right now, so I'm going to show you guys this really cool reaction. Okay, so what I'm going to be doing is I'm going to be adding some glucose into the bottle. That's right. Funnels are for losers. That's why I'm a professional. So that's glucose. Next, I'm going to add some potassium hydroxide. And the reaction is actually starting right now. But you can't see it. Because we also need to add some methylene blue dye. And then we're going to put the top on it. We'll swirl it around for a minute. So this is called the blue bottle experiment because when you shake it up, it turns blue. And we're actually adding oxygen into it, and the more you shake it, the darker it gets, and the longer it takes to reach equilibrium. So I'll put it back down on the counter, and it'll take, I'm going to guess about 15 to 20 seconds once it's reached that equilibrium point, and it will turn clear again. And if you look here on the top layer where there's oxygen, you can see that there's still a blue line around it because it's actually, oxygen is diffusing in still. So the first step of this reaction is the enolate of the glucose is formed. Now, an enolate is where you have a double bonded oxygen and you're going to go and cleave one of those bonds, and suddenly you're left with a single bonded oxygen with a negative charge. And then you're going to get a redox reaction with the enolate of the methylene blue, which is the dye. So we're going to be adding the oxygen bond to there. So the net reaction there is that the glucose is actually oxidized to gluconic acid, which, because we've added potassium hydroxide, you actually form sodium gluconate. Finally, the methylene blue is actually reduced to leucomethylene blue, which all of that together means that it turns blue and then clear again. So if there's enough oxygen, which is what happens when you shake it, you're adding oxygen, the leucomethylene blue gets oxidized back into methylene blue. So at this point, the blue color is going away, it becomes clear, and the glucose reactions that I described earlier starts over again. And then the whole system repeats over and over again. As long as you're adding more oxygen, it goes from clear to blue. And it actually does it for a good hour or two. So it's something you can set up ahead of time, have a lot of fun with, and if you're out doing a demonstration where you need to do some chemistry magic, this is an easy one to do. Well, you're no fun. So this is the blue bottle experiment, and when you shake it up, it turns blue. And then what's happening is we're dissolving oxygen in there, and that's reacting with some glucose and some indicator dye. And once the reaction proceeds through, you remove the oxygen, you're forming some hydrogen peroxide, which then goes back in the water, and it turns clear again. Kind of cool. Yeah. First time I've ever done this.